Man, the tech world, right? It's like a never-ending sprint.
Yeah, tell me about it. Every single day, there's this avalanche of new information.
It can be so overwhelming, just trying to keep up. I bet our listeners feel it too. You want the signal, not just the noise,
Yeah, exactly. That's the whole point of what we do here, I think, cutting through the clutter.
And today, we're doing just that with Jensen Huang's GTC 2025 keynote. He's the CEO of Nvidia, of course.
Huge event, so much to unpack, but we're giving you the express lane version, the need-to-know stuff.
Right. So think of this deep dive as your shortcut to understanding the announcements that really matter, especially for AI and the automotive industry. Those are our two big focus areas today.
Sounds good to me.
So let's get into it. Nvidia and self-driving cars, that's been a long journey for them, right? About a decade now.
More than a decade, yeah. And the thing is, it wasn't some carefully plotted course they charted from the start. It was more like
More like what?
there was this unexpected turning point, a pivotal moment in AI research that completely changed their trajectory.
Okay, I'm intrigued. What was this turning point?
It all goes back to something called AlexNet.
AlexNet. Even the name sounds kind of revolutionary.
Well, it's pretty revolutionary, I'd say. So picture this. It's 2012, and you've got this highly competitive computer vision challenge called ImageNet. And this neural network architecture, AlexNet, enters the scene.
Neural network architecture. So we're talking about the very blueprint of how an artificial brain processes information.
That's it. And this AlexNet, it didn't just win, it absolutely blew away the competition. I mean, its accuracy in recognizing objects and images, it was 84.7%.
Wow, 84.7%. That's a huge leap forward.
Right.
What was so different about it compared to what came before?
A few things. One was its sheer depth. AlexNet was a massive neural network, way more layers than previous designs, and this deep architecture. It allowed the network to learn much more complex patterns from the data.
I see. That makes sense. More layers, more depth, more complexity, hence deep learning.
Exactly. And they also used this new kind of activation function called ReLU. It really sped up the training process.
Fascinating. So who are the masterminds behind this AlexNet breakthrough?
The key players were Alex Krzyzewski. He was the lead author of the paper. Then there was Ilya Sutskever, who went on to co-found OpenAI, a pretty big deal these days.
Oh, wow, yeah.
And the legendary Geoffrey Hinton, a true AI pioneer. Their work with AlexNet was a major turning point. It proved that scaling up these neural networks, making them deeper, had immense potential. It really reignited interest in deep learning across the entire field.
So this is the moment that caught Jensen Huang's eye.
Absolutely. Huang himself has said that seeing AlexNet's results was a true aha moment. He understood immediately that this AI breakthrough was a game changer, especially for the future of transportation. And that's what led Nvidia to go all in on autonomous vehicle technology.
It's pretty amazing that one single research outcome could have such a dramatic impact on a company's direction. So after this all-in moment, where does Nvidia stand in the autonomous vehicle landscape today?
They're everywhere. They've built partnerships with so many automakers, like a huge number of them, and major suppliers too, plus all sorts of tech companies working on self-driving technology.
So they've woven themselves into the whole ecosystem.
Exactly. And just at GTC 2025, they announced this expanded collaboration with GM. That was a big deal. It shows how committed they are to this industry.
Can you give us some specific examples of how NVIDIA's technology is being used out there in the real world?
Sure. Look at the big players like Tesla, Wayve, Waymo. They're all using NVIDIA's powerful GPUs in their data centers.
GPUs, those are graphics processing units, right?
Right, and they're perfect for the kind of parallel processing that AI and machine learning require. So these companies are using them to process massive amounts of data, to train their self-driving algorithms, and to make them better and better all the time.
So even beyond the cars themselves, NVIDIA's technology is playing a crucial role behind the scenes.
Absolutely. And there's more. NVIDIA also has this platform called Omniverse.
I've heard of that.
It lets companies build these super detailed digital twins of their factories.
Digital twins, so like virtual factories.
Exactly. It's like stepping into a video game version of their production line. And this lets them test out manufacturing processes virtually. They can even design new cars entirely in the virtual space. It's incredibly efficient.
Wow. That's fascinating. What about the technology that's actually inside the cars, the stuff on the road today?
Well, you've got big car companies like Mercedes, Volvo, Toyota, and even companies like Zoox. They're all using NVIDIA's Drive Orin computer system on chip. It's basically a super powerful, highly integrated computer that acts as the brain for these cars. It handles all those advanced driver assistance systems and eventually full self-driving capabilities.
I see. And it's based on Nvidia's Ampere supercomputing architecture.
That's right. And on top of that, you've got companies like Toyota using NVIDIA's Drive OS. It's an operating system built specifically for autonomous driving, with a big focus on safety.
So it's clear that NVIDIA is not just providing parts. They're deeply integrated into the entire development and deployment process of self-driving cars.
Yeah, it's really impressive how they've become this fundamental driving force in the autonomous vehicle industry. From that initial spark with AlexNet to their current position, it's been quite a journey.
Okay, let's shift gears now and talk about those personal AI supercomputers that Jensen Huang unveiled at GTC. That sounds like something straight out of a sci-fi movie.
It does sound futuristic, but it's actually happening right now. And it's all thanks to their new Grace Blackwell chip platform. Huang actually introduced two different machines in this new category.
Okay, break it down for us. What exactly are these personal AI supercomputers?
Well, the first one is called the DGX Spark. You might remember it from its earlier codename, Project Digits. Nvidia is calling it a personal AI supercomputer, and it's powered by a single GB10 Grace Blackwell superchip. What's really remarkable is its processing power. It can handle a mind-boggling 1,000 trillion operations per second, all dedicated to AI computation.
Whoa, 1,000 trillion operations per second. That's like having a data center on your desk. And you said this is actually available now.
That's right, it's available right now.
Wow. What kind of tasks would even require that level of power on a personal workstation?
Think about things like training massive language models, developing incredibly complex AI for generating images or videos, running super sophisticated simulations. Those are the kinds of tasks that used to require huge computing clusters and data centers. But with DGX Spark, you're bringing a significant chunk of that power down to a much smaller scale.
I see. So it could really accelerate the development process for AI researchers and engineers.
Absolutely. It's all about speeding up those cycles of prototyping and fine-tuning.
Okay, what about the second machine? What's that one called?
That one's called the DGX Station. And it's even more powerful than the DGX Spark. It uses NVIDIA's GB300 Grace Blackwell Ultra Desktop Superchip and has a whopping 784 gigabyte of memory.
784 gigabytes of memory. That's insane.
It is pretty wild. The DGX Station isn't available just yet, though. It's expected to be released later this year through a bunch of different manufacturers. NVIDIA mentioned Asus, Box, Dell, HP, and Lenovo as partners who will be offering systems built around it.
Got it. So Huang called these the computer of the age of AI. What exactly does he mean by that? What's his vision for these machines?
He believes that we're entering a new era of computing, one that's specifically tailored to the demands of AI. He sees these personal AI supercomputers as the fundamental tools we'll need to work with AI models throughout their entire life cycle, from the very first prototype to the final, fine-tuned model and everything in between. And not just that, he sees them enabling us to run these models, even the really big ones, closer to where the data is actually being generated and used, at the edge, so to speak.
So it's not just about replacing our old clunky workstations. It's about enabling entirely new ways of working with AI.
Exactly. Huang made a really interesting point about how we're moving into a world where AI agents will be everywhere. Think super advanced virtual assistants, autonomous systems built into every device imaginable. He argues that the way we interact with and use AI is going to change completely, both for companies and for individuals. And that requires a whole new class of computing hardware. These personal AI supercomputers are NVIDIA's answer to that challenge.
So it's about democratizing AI, putting powerful tools in the hands of more people.
You could say that. By making these powerful machines more accessible, they're potentially opening up the world of advanced AI to a much wider range of users, not just big companies and research labs.
That's pretty exciting. Okay, so let's wrap this up. Our deep dive into Jensen Huang's GTC 2025 keynote has highlighted two major interconnected themes.
I'm listening.
First, NVIDIA's decade-long commitment to autonomous vehicles, a journey that was really ignited by that unexpected breakthrough with AlexNet and the whole explosion of deep learning that followed. And second, the introduction of these groundbreaking personal AI supercomputers, the DGX Spark and DGX Station, which are specifically designed for this new world of AI agents that Huang described.
Spot on. It makes you think, doesn't it? If these personal AI supercomputers really do become widespread, how will that change the landscape of innovation? I mean, we saw how one powerful AI model, AlexNet, could change the course of a tech giant like Nvidia. What could happen when even more people have access to this kind of power?
And it goes way beyond just self-driving cars. What other industries could be on the verge of huge transformations thanks to these advancements in AI algorithms and the hardware that makes them possible? Healthcare, scientific discovery, maybe even the arts. The possibilities seem endless.
It raises a really fundamental question. Where will AI take us in the next 10 years? What amazing discoveries and innovations will emerge inspired by the progress we're seeing today in deep learning and computing hardware? It's a constantly evolving field, so who knows what the future holds?
Well, one thing's for sure. It's going to be a fascinating journey.
Absolutely. And for our listeners out there, we encourage you to stay curious, keep exploring. The world of AI is full of surprises, and it's only getting more exciting.
Couldn't have said it better myself. Until next time.
See you then.